Hi, good afternoon now. Thanks for this session. It became a very long story. It cannot be used against me. So we are friends, but policy hasn't changed. Sorry about that, but this session is going to be about infrastructure. And to make things rolling now, I want to talk about OCI, Oracle Cloud Infrastructure, how we build all our platform. I'll try to be a bit fast. We have tomorrow a 60-minute session that you can join here. Oracle has built regions based in availability domains. We built 3 ADs per region, and on top of each AD, we have a physical data center. It's a spine leaf architecture, or what we call closed. 1 million ports inside each, really flat. So you have 2 hops between any 2 devices inside, really extreme low latencies. On top is what we have our key element when we designed this platform. We took the software-defined network out of the hypervisor, so it gives us true scalability. But moreover, we can give you bare metal service, but you can have engineered system. Not sure if you know Exadatas. You can run your Exadata and your bare metal stuff all together in a single network. All the cool thing about this is all our storage is based on non-volatile memory express. If you single or multi-tenant, you have the same set of APIs there. We do not do over subscription, neither on CPU, neither on network. We don't do compute resource sharing. So whatever you put for your VM will be physically done for that. And on top, we provide a government model. We call it compartments. Think of that like folders where I put all my resources I define. And I can do it by projects, line of business, or even customers. So I can segregate everything. You can add tags, so for billing and stuff like that, you can go over the details. Everything API managed and stuff like that. And we are the first guys out there giving full SLAs. It's not about service availability. It's about service manageability and network performance. You have SLAs tied to how our network runs, but also on disk IOPS. So you will be covered fully as an enterprise. This is how we mentioned about architecture. 200 microseconds RTT when you get inside the availability domain, 1 million ports. Currently, the network is running on 25 gigs. We're already working to speed that up to 50 gigs. And you guys came and said, this is very good architecture, but you don't have a very extended landscape. So we changed the approach and we say, okay, let's try to build a region with a single availability domain. And as more demand we get, more availability domains we build there. So we are bringing 1 data center every 23 days for the next 15 months. We plan to have 36 regions by end of calendar year 2020. We'll cover the whole world to get things done. So for those areas, we came and thought, okay, why don't we give what we call fault domains? They are different set of hardware stacks inside the data center, so you can split your application between both of them. You can choose any fault domain there. So in the application, you have several web front ends with web servers and stuff like that. You can just split them between. So you ensure that if there's a failure in one fault domain, you can still have the application in the rest of that. This is important because this is how we're going to deploy VMware stuff on top of our bare metal service. So we split in different physical hardware stacks. This is how it looks, the network. Mostly similar to what you've seen in other cloud providers. We call it virtual cloud network, so SDN stuff. You have private network with your subnets, your route tables, and your DHCP options. Everything is secure with firewall rules or access lists if you are from the old school. We also have it because usually access list is based on the subnet, but if you want to do it on the virtual NIC, we have what we call network security groups. So even inside the subnet, I can specify who is going to talk with whom through which virtual NIC. Then the most important thing is the communication gateways. We have 5 different things out there. We call dynamic routing gateway, or DRG. Is the way you connect back to your data center over Fast Connect or VPN. Our Fast Connect solution is you pay for the port 110 gigs. Whatever traffic you put inside is for free. We do not charge for network egress traffic when you use the Fast Connect. And when you're using the front-end services in the internet gateway, you have 10 terabytes. I repeat, terabytes of free traffic when you run your services. We're removing costs in small and medium enterprise companies. Then we have the LPG, local private gateway. It helps you to connect two different VCNs. If I have applications running in two different ones, I just can peer them and secure with access list. And then we have the service gateway. Is what we have Oracle Network Service, where you have the autonomous data warehouse, autonomous transactional, object storage, telemetry, and all the public services. It's away from whatever you have defined in your VCN, you can access internally. So we are securing the storage packets, and now we are announcing that as private IPs inside your VCN. And moreover, we came with a solution that we call transit VCN. So from your data center, any IP inside your data center can reach directly the network service to store things in the object storage and to make use of other services there. And the NAT gateway, everything's for free, no charge on that. The NAT gateway, we found people deploying instances just to use it as a NAT. So we thought, why don't we bring that capability for free? So you just deploy this and you have your own NAT instance to deploy inside your environment. This is how it looks, the whole picture. When we talk about internet with internet gateways, NAT gateways, how I peer between LPGs and the dynamic routing gateway, how I connect back there. The thing is now, people asking, how can I bring the whole VMware stuff and make it run with Exadata? Let's bring the best of both worlds and run it in a single cloud platform. The idea is not to bring the whole VMware stuff with a virtual database. It's take the virtual database out and make it run natively in Exadata cloud service, subscription model. I will talk how it looks like. This is the architecture. There are different scenarios. I can have everything in a single AD. That's for mono regions. How can I deploy the stuff? Different fault domains. So I ensure that everything runs in a different hardware stack. You have also, I can do peering. So I split and I have my Exadata on one side. I have my VMware on the other one and just communicate between them. And you can extend it. We have regional subnets. So I can span across the 3 ADs inside a region. So there are 3 different data centers. I can have one host in AD1, AD2, and AD3, and everything is interconnected. There are many more scenarios, so I want to just to try to limit. And I want to show how to do it the first one when you have just a single region inside a single availability domain. And all the process from you go from how we create, you have your tenancy, you can define your compartments and your stuff, but the first thing I need to create is my virtual cloud network. I'll create virtual cloud network with 172.16.0.0/16, and now I need to define for the Exadata cloud service. You usually define 2 private subnets, one for the client side and the other one for the backup. The backup is the one that's going to connect back to my object storage to allocate whatever things you need there. And then VMware stuff, we provide a SDDC image that you will deploy it. It comes with ESX, a cluster of NSX, you have vSAN, and you have the vCenter. The cool thing of this solution is that it's not a managed service. We give you the root credentials of your ESX environment. You will be able to manage and update whenever you want. You don't have to keep the pace of the other cloud providers that I put a new version and I push you to get updated. No. If you need to test your things and you need to do your stuff, just do it on your own. You have full control. For security, there's companies that have third-party companies managing the environment. They will keep doing the same stuff in our cloud. I think it's the main key differentiator when we talk about managed and not managed there. But there's some warnings when I create subnets. Try not to use Exa Cloud Service subnets for other applications. Just focus on this main thing. Try not to hit 192.168.128.0 because it's the InfiniBand subnet space. With the new X8, that is a beast of hardware we're rolling out now, we just changed InfiniBand and now we're running Rocky. It's remote direct memory access over convergence Ethernet. 100 gigs running down. You will see it soon in our cloud environments. And then the other one is about DNS levels. Try to keep 14 characters when you define these things. So, how I route all this stuff. When you're inside the VCN, it does it for you. So you just need to focus on where I want to connect to. For example, my client subnets, I need to connect them back to my data center because people is going to access there. So I route my on-prem subnets through the DRG. You have also a default gateway for the NAT, and I want to use to object storage or get another database, whatever. So I put it through the service gateway. Same thing for backup, but I just want to use to object storage. And then for the VMware stuff, we route that through an IP, private IP, that is the VCN or SDN side, so you can get out. But then we route also all the subnet ESX guests. Through that one, you have a default route through internet, and you get all services also through that side. So the real thing is, I need to secure. I know how to route, but now I want to limit who is going to talk with whom. This is how it looks, some of the ingress, egress rules. You access SSH, but I want to put ICMP type 3 code all. Usually it's because we have the MTU path discovery and the VCN error login, so we use that to identify any error we can have there. But you get access to the SQL listener from what we're going to have there, or all ICMP. Same thing for the backup. I just want SSH and use all the object storage, so I will allow that. But for the VMware stuff, you have RDP, you connect everything through the guest, so I just define who is going to speak with each one. And I'm running because I'm just 1 minute late, and you will say, yeah, this is OCI, what about VMware? Okay, this is what we are going to deploy. An NSX Edge, 2 tiers, tier 0 is static routing, and then one on tier 1 we do redistributed connected, so just we push whatever you have on your environment, you get that connectivity. There's a routing link between those, that is 10.16.0.0/10, that is the interconnect. Usually you use Ravelo service. You know, when you trace and try to get out of the hypervisor, you get that IP addressing scheme. This is how it will look, the whole stuff between the VM down. It hits our virtual network, use the service gateway, use whatever service inside Oracle. Physical devices on the back. This is currently X7 stuff, what we are using there. You can have 50 cores, 51 terabytes of non-volatile memory space, 768 gigs of RAM. And these are the 2 sessions today covering, and you have tomorrow one for 60 minutes. Sorry about that. If you want more, just follow me, and we can keep talking about techie details. Thanks very much, guys.